Okay, welcome back for part 2 of the Alpha DCVax progression-free survival model review. I do have a disclosure. I am long on this stock and I have no insider information. I am a clinical researcher. So where we left off last is we showed the model based on the published NWBO number of events on 2 time periods, one in December 13, the other in February 17, giving the number of events for the total group. Now, using those data points, we were able to model the potential difference between the control and the experimental arm of the DCVax-L. And in order to do that, we utilized the IMUC data set. And when we put that through, we obtained this curve. Now, several other posters have requested additional information on how this is done, including Jamie James, who wanted more details. Also, some very smart posters also noted that I did have an incorrect N. I was using this model before the translational medicine came out, and these were my N's for the control and the experimental. The true N is actually 99 here, and the balance being here. So we made a correction for that. So the first thing we do when we start a trial like this is we have to really dissect out the control curve of the IMUC data, and I will next show you how we start doing that. All right, so in order to make the model, I had to print off the progression-free survival for the IMUC survival curves, which are noted here. I also note that in the IMUC data, the N was 43, and they have 39 events listed here. So we have to do some basic math. There were 39 events out of 43 cases in the IMUC, and using the current DCVax N of 99 in the control, 43 equals X over 99, X equals 90 events in the DCVax. We should expect, if the DCVax control population goes exactly the same as the IMUC control group, we would expect 90 events. So in the DCVax, there would be 9 who did not event or who continued to not event by this time period. Also note that with the IMUC, virtually everyone had evented by just over 700 days here. So approximately 2 years. So that's one thing. The other thing then I did is I measured with a very fine ruler, and I have a magnifying glass. This is the painstaking, tedious part. And 100 days on this graph equals 17 millimeters. 8.5 millimeters equals 50 days. And each tick down is an event. So here's one event, 2, 3, 4, 5, 6, 7, 8, 9, 10. You do this and you actually count up exactly what they've said here, 39 events. So this painstaking part is you got to go to the first event here and put this up, make a little mark down here, measure that mark, get the millimeters. I put that into an Excel spreadsheet and then convert it to days, which ultimately will be converted to months. Once that data is in the spreadsheet, then you have the IMUC data that you can use for modeling. So in order to start our model, we first have to put the IMUC data into an Excel spreadsheet in numerical format. And this is just the Excel spreadsheet. If you look here, column A is just a patient number. We have patient 1, all the way down to patient 331. So basically, each row represents a potential case or a patient in the DCVax trial. Next, we have whether they're in the experimental arm or the placebo. So number 1 will be experimental, 2 will be placebo. So number 2 there will have 99 of these patients. Now I'm going to do a survival curve here at a future modeling, and so I'm just doing progression free, so this one I haven't yet completed. But for progression, I have 0 equals no progression and 1 equals that they did progress. And then the key element for a Kaplan-Meier curve is time. And in here I have the millimeters actually of distance on the x-axis from the IMUC curve to the event. And then it was, I think, 17 millimeters equals 100 days. So then doing that ratio and then adding the 83 days with this formula up here gives you then in months where that event occurred. So for a Kaplan-Meier, you need a time element. You need to know whether they have progressed or not. And then you need to know which group they're in. Those are the only 3 things that you need in order to run a Kaplan-Meier analysis. So I'm going to switch now to the statistical program, the survival analysis, which is right here, utilizing XLStat, which is up here. That's an add-on statistical program that I was able to purchase. Actually, that's what took me so long this weekend because mine was outdated and I had to repurchase it. So I just input this data into the statistical program here again, and you can see the data right here. So fairly easy now that you got the data in there. The other key thing to show is this time represents data directly from the IMUC curve. So each event for the DCVax control arm, I think, was equal to 2.3 events because the N was greater. We had to do the ratio, and each event for the experimental arm, each event of the IMUC curve would be equal to an additional 1.75 events. So you have to make the number of events equal in order to make your model exactly the same because of the different N with the IMUC versus DCVax. So these are all of the data points here. And I used the control data for both the experimental and the control for the DCVax because we need to keep these exactly the same, because what we're looking for here is the difference between these two. So these numbers may not be exactly correct, but what we're really after is what is the difference between the control and the experimental arm, and is that significant? So here we're still in number 1, which is experimental arm, come down here, and number 2 represents the start of our control arm, and again, the numbers. Now, for the patients who were still present that we didn't have enough of the events, I did the same on both the experimental and the control and just gave them a 36-month follow-up. Now, this likely is being conservative because many of these patients probably were censored out even before this. The key thing, I did the same thing for the experimental. So just like a mathematical formula, whatever you do on one side, you have to do on the other to make them equal, because we're comparing the difference. So I realize that this is not accurate for the likely outcome, but it will be accurate for looking at the difference between the two curves, which is what I'm really interested in. So that's the people who did not event in the experimental arm. We're just given this because I don't want to guess. And many of these have much longer numbers, of follow-up. And I can only use up to 2 years based on the IMUC data. The rest would be kind of a guess. But this will show a difference between the two curves, which is kind of what we're after. So then you click on your Excel stat up here, and there's a bunch of ways to analyze this. What I'm going to go over here is you'll be amazed at how simple this is once you have this set up. Kaplan-Meier analysis, so this pops up. The time element is here in G, time to last follow-up or progression. The status indicator is D, progression-free survival, 0 equals no, or progression equals 1. You have to give it the range, which is the whole sheet. Then you do have to go into group by group and then tell where the grouping is, and the grouping is over here. One represents experimental arm and one placebo. So when you click OK, it's amazing how quick this is. Hit continue and boom, you have your data here. And voila, you have your Kaplan-Meier. So we have our total observed is 232 in the experimental arm and 99 in the control group. So the first analysis here, this is the Kaplan-Meier table, which we'll see in a graph format here shortly. And what you can see here is this is the experimental arm with error bars. One thing to note is the median survival, 50 percentile, is 16.27 months. That's the 50th percentile right here. And then the next one would be the control, which is right here. And again, the 50th percentile is 12.59. And you look at the comparison right here with a p-value of less than 0.001, so very highly significant. The thing that I would like to point out, though, is that the median is pretty close, actually. We look at the medians here, and it may be this is why the company caused the trial to be expanded and why the company has pretty much vehemently wanted longer-term follow-up, because a lot of oncologic drugs are reviewed based on the median, which in this case you can see the median would not be as significant as this tail. So the longer follow-up will give us a much better view of what is happening with progression out here. And this is where we find the real difference between these two curves. So I just want to make that point with this. So basically that's how I do these models. You can do a lot of other things, like for example, I did another one here, and I just changed this for the people who did not event. I changed it to the average, which would be the average of the longest follow-up of 27.87 months and the lowest, which was 4.86. So I took the average, was 18.25. So I figured, well, let's do the kind of worst case scenario here. What if everyone censored out earlier on? So I did that both with the experimental, and you have to do on one side, you got to do it on the other. I did that with the non-eventers in the control population. And so when you do that, you know, the curves tighten somewhat. They still tighten. The tail is less. Still a significant difference, however. So this would be what I would term the worst case scenario. I believe that our numbers would actually be quite a bit better than this because we have a lot longer follow-up, and we know the company has disclosed that we have had long-term survivors. People are living longer. And so I don't believe this worst case scenario is what is really happening. However, even the worst case scenario in this model returned a p-value of 0.004. So that made me feel a lot better. Again, the medians, a little tough to use median of 12.59 versus 16.27. So I think the company is on the right track of having the long follow-up. I'm very excited to see what the results are. My best guess, hypothesis is based on these models is that we're going to see positive results in progression-free survival, which is the primary endpoint of this study, but also, I believe, overall survival and on various subset analysis. So to go back and leave you with the final model, this is what I think is happening. This is my current model using the new ends based on the IMUC data, and that looks pretty significant. Thanks for tuning in, and good luck. Thank you.